Hello everyone, welcome back to the channel. In this video, we are going to look at problem B from today's AtCoder Regular Contest 154. The name of the problem is New Place. So according to the problem statement, we'll be given two strings S and T of equal length n. Both will consist of lowercase English letters, and we can perform the following operation any number of times. So the operation is that we can erase the first character of string S and we insert that character at any position of string S. So we can perform this operation any number of times on string S. We need to determine whether it is possible to make string S equal to T. And if it is possible, we need to find the minimum number of moves required to make both the strings equal. And if it is impossible, we have to return, we need to print -1. So this is the problem statement. In the input will be given n, which is the length of both the strings, and then in the following two lines will be given string S and string T. Now let us understand the approach to solve this problem. So basically we'll be given two strings of equal length and we need to determine whether we can make string S equal to string T by performing the given operation few times. And if it is possible, we need to find the minimum number of moves. So firstly we are going to see when we need to return -1. In this example, as you can see that both the strings S and T are made from the same characters and the frequencies are also same. Hence it is possible to make string S equal to string T. So if I write the operations, so from A, R and C we are going to delete A, which is the first character, and place it at the last position. So we will get RCA. So this was the first move, and then in the second move we are going to delete R, which is at the first position, and place at the second position in the string. So we are going to get CRA. So as you can see, in two operations we were able to make string S equal to string T. Now coming to the next example, here the thing is both the strings are made from different characters and their frequencies are also not same. Hence no matter how we perform the operation, it is not possible to make string S equal to string T because the characters are not same. Hence in this case we will print -1. So here the first conclusion that we get is that we are going to check if both the strings are made from the same characters and their frequency should also be same. So if the characters and the frequency of the two strings are not same, then we will print -1, because in that case we cannot make string S equal to string T. So this is the first thing which we are going to perform in our code. If the characters and their frequency in both the strings are same, then we are going to move to the next step, which is to determine the minimum moves required to make string S equal to string T. Let us consider this example. So in one move we can delete the first character of string S and we can place that character at any position in string S. So let us see in how many moves we can make string S equal to string T. In first move we are going to delete Y and we are going to place it between D and M, right? Because y comes between d and m, that's why we are going to place it between d and m. So it will be, so after performing the move one time, we get this string. Now again we will perform the same operation. We will delete v and we are going to place it between d and y, because in string t v comes between d and y. As you can see, character v comes between d and y, so we will place it between d and y only. So in after performing the operation second time, we will get a I d v y m, right? Now again we will perform the operation third time, and we are going to delete a, and we are going to place it between y and m, because in the original string a comes between y and m. So we are going to place between these two characters. Okay, now again we will perform the operation one more time, and we are going to delete I, and we will place it between d and v. So between these two characters we will place I, so we will get d I v y a m. So as you can see, in 4 moves we were able to make string s equal to string t, and this is the minimum operations. Let us see one more example and it will be more clear. In string s, only 2 characters are not in their correct position. Rest all the characters are in their correct position. But still, let us see how many operations we need to perform to make string s equal to string t. So in the first operation, we will delete character d. We are going to place character d before character a. So before character a, we are going to place character d between I and a. So in a while we'll understand why we are doing this. So after performing the operation once, our string s will be, so this will be our string s. Now again we will perform the operation second time, and we will delete character y, and we will place it between d and a, because in the original string y comes between d and a. So our string will become, now again we will perform the operation third time, and we will delete character v, and we'll place it between d and y, because in string t v comes between character d and y. As you can see, v comes between character d and y, so that's why our string will become I v y a m. Now again performing the operation final time, for the fourth time, we will delete character I, and we will place it between d and v. As you can see, I comes between character d and v, so it will become d. So as you can see, in this case it took 4 operations to make string s equal to string t. In order to find the minimum number of moves required to make string s equal to string t, at the end of string s we are going to find the length of the longest subsequence from string t, because in one operation we were deleting the front character and we were placing it at the appropriate position. So if we determine the length of the longest subsequence, then it will become easier, because it means that all the remaining characters need to be placed accordingly to this subsequence. So in this example, the longest subsequence that we got was A and M. Uh, excluding excluding these characters, all the remaining characters need to be positioned again. This gives us the minimum number of operations required to make string s equal to string t. Okay, coming back to the previous example, in this case the longest subsequence length is again 2, which is d and m. In the original string, these are the two characters, and at the end of string s we get this subsequence. Apart from this subsequence, all the remaining characters in the front of string s needs to be positioned again. So the minimum operations would be n minus the length of this subsequence, which gives us 4. So if I conclude it again, in string s, dm is the longest subsequence of string t, which is present at the end of string s, and all the remaining characters in the front need to be repositioned according to this subsequence. So length of this subsequence is 2, and total length minus 2 gives us 4, which is the minimum number of operations we need to perform. Now I hope the solution was clear. Now let us move to the coding section. So firstly, we are inputting the length of strings s and t, and here I have inputted both the strings, and here I am checking if the strings are already equal, then we will print 0. Otherwise we are checking if the characters of both the strings are same and have same frequency. So for that we will iterate through both the strings one by one, and here I will check if the frequency of each character matches. If it does not match, we are printing -1 and we will return. If the frequency of characters in both the strings are same, then we will move to the next part. So we need to determine the minimum operations required to make string s equal to string t equal to the second string. So for that we are finding the longest subsequence length of string t present at the end of the string s. Our minimum number of operations required would be total length minus the length of the subsequence. So you can go through this part of the code. I would suggest to write this part of the code on your own. If I try to run this code, as you can see, all the test cases were passed, and output of this test case is also correct. This is the custom test case given by me. And if I try to submit this code, as you can see, our solution got accepted. This was it for this video. If you are new to the channel, please consider subscribing, and that's all. Thank you.